So medical applications of blockchain are potentially hugely significant, particularly as inaccurate medical records are thought to have contributed to a large number of deaths. So this is potentially a matter of life and death, so obviously important enough for a blockchain solution. The hope is that there can be a reduction of waste and fraud as well, that could be facilitated by more accurate record keeping facilitated by blockchain. In terms of long-term safety, it's also potentially possible to use blockchain to, for example, monitor the safety of medical devices. Further applications include blockchain-enabled databases of physician credentials. So the point here is to try and get consensus and as close to absolute truth as humanly possible. Hopefully also an immutable data record. Other applications might include blockchain-enabled disease registries. So that was important before the pandemic, but also of obvious potential interest now. And another thing here might be blockchain-enabled databases of clinical trials. So remember, blockchain is designed to try and ensure trust in a trustless environment. Here it might be almost able to compel pharmaceutical companies to share the results of failed trials. So in terms of energy and food applications, one of the things that we've seen before is that blockchain could potentially help you to track provenance throughout a supply chain. So this is just literally being able to tell with a high degree of accuracy where something has come from and how it is being used. So this general idea has particular worth in the energy sector, and this might variously mean that you can enhance the production and delivery of energy and indeed make the associated financial markets more efficient. So the idea here is that in the food sector, establishing the provenance of food may variously improve food safety because you can track the supply chain more closely, more accurately, and also at the same time potentially improve profits for farmers because attribution is easier with a blockchain enabled accurate record. So there's all sorts of potentially contemporary applications here to do with this tracking provenance throughout the supply chain. I can't help wonder about possible applications with respect to Brexit, for example. I know another contemporary example has been application of labour standards throughout the supply chain. Other examples as well, I'm sure you can think of. So in terms of energy logistics, so this is a deceptively complex problem, and the main motivation here is the sheer complexity of the system caused by the sheer number of individual participants. So many complicated logistical processes generate multitudes of administrative data. A key example here is energy logistics. So the idea is that you could potentially manage this system and extend existing systems using blockchain management. So example logistical challenges include the following. So in North America, you might have, for instance, generation of power in Quebec in Canada, which is then transported overseas to, say, Massachusetts in the US. You might also have examples where you have, say, the deployment of heavy equipment, e.g. at extraction and production sites. Could potentially be a very, very large problem. Things like open cast mining and coal oil extraction, for instance. And just any general example where you have complex supply chains involving suppliers, contractors, subcontractors, subcontractors, service providers, etc. So in this case, as we've seen before, it's the sheer complexity of the problem caused by the number of participants in the system which motivates a blockchain solution. So alongside this, another potential application is blockchain grid management. So again, the motivation here behind a blockchain solution is just the sheer complexity of the system corresponding to the sheer huge numbers of individual nodes in the network. So this is potentially much more complex than it might sound. So as an illustration, consider for instance solar generation technologies installed at home. So the idea is that customers might then be able to send surplus energy back to the grid, e.g. at times of peak solar production. And the idea is that microgrid blockchain companies might be able to reduce costs for consumers by increasing the supply of energy. So in Sharia 2020, there's a suggestion that blockchain may also be used to track the source of generated electricity, e.g. to check that green energy was used rather than gas or oil. So going back to this idea of checking provenance throughout the supply chain. Okay, but you can hopefully sort of see here, if you've got multiple individual participants in the system, say sending surplus energy back to the grid from their own solar technologies, it's potentially a very, very complex system and a very, very large system containing lots and lots and lots of little bits. So in terms of food applications of the blockchain then, so this main idea that is important is the traceability of supply chains and being able to establish provenance. So it's thought that this might have important implications for food safety. So if you've got better knowledge of provenance enforced by blockchain, it might make it easier, for instance, to check the source of a salmonella outbreak or another instances of food poisoning. And in terms of food governance, there's potentially wide-ranging applications. So blockchain environments and checking provenance at every step through the supply chain could variously enable blockchain environments to ensure that food is free of certain chemicals, minimal labour standards are met. So this has been a big deal with respect to contemporary anti-slavery applications. And the idea is as well that hopefully distributed ledger technology can ensure a fairer match between supply and demand. And an application to Cambodia rice farmers is discussed at length in Sharia 2020. And the idea here as well is that you can enforce higher velocity in the supply chain. So as discussed at length in Sharia 2020, the idea is that you might be able to, for instance, use blockchain technology to speed up the processing of large shipments in the soybean market. So blockchain applications are potentially very wide-ranging, not just the technical gubbins behind digital currencies. So as with other examples that we've seen earlier, really the important point here is the complexity of the data set, potentially just the sheer size, and a problem that's complex enough to warrant a blockchain solution. So one extension of these ideas is that the physical world can be made easier to understand and interact with through the application of blockchain to newly available data sets. So it's the complexity of these data sets that's motivating a blockchain solution. So the idea is that real estate can be bought, sold, developed and maintained more efficiently, more effectively if you're using the blockchain as essentially an information management device. So the intersection of environment, policy and economics can be vastly improved through distributed ledger technology. So again, the idea is to try and manage the sheer complexity of the data sets involved via a blockchain. And alongside that, the idea is that natural resources such as gold and other commodities like real estate can also be more readily transacted, and precisely because the complexity of the data involved can be potentially effectively managed using a blockchain solution. So one of these novel applications of blockchain relates to real estate. So in this case, the application of blockchain to real estate is variously intended to counter closed information systems and archaic data sets. So these are long-standing problems that you want to try and resolve here. And I think there are two main parts to this. Firstly, this idea of trying to establish trust in a trustless environment via blockchain. And secondly, as we mentioned before, just the sheer complexity of the data sets involved. So the blockchain-enabled features are intended to make data sets smaller and more granular, therefore more widely available and shareable. So if you can split the data set up into smaller and smaller bits, you've potentially got more things that you can buy and sell and transact with. Alongside that, you need both accuracy enforced by the blockchain, and the blockchain can also manage the increasing complexity of the system. So the idea is to attach a digital data set to an underlying physical asset, essentially split the thing up into smaller bits that you can buy and sell more readily. And the idea is this can variously improve the velocity of information flow of goods and services, and increase economic productivity and to reduce costs. So in terms of blockchain application to real estate then, so historically real estate was subject to transactions in very large ungainly problems. Okay, so you tend to transact in very large blocks, literally whole houses, and this is a very hard market to get into. So the idea is that blockchain and tokenization means you could reduce real estate into micro-fractional elements. For instance, you could perhaps own a corner of your favourite coffee shop when these things existed and it was possible to go to these things. You split things up to smaller bits, so there's literally more activity in terms of the things that you're able to buy and sell. Now, alongside that, there's a potential for blockchain to render whole reams of bureaucratic and legal tasks obsolete. So these could be automated by blockchain, especially in commercial real estate. So I'm not saying this is necessarily a good thing. It might potentially result in wholesale redundancies of skilled administrative jobs. So examples that might be amenable to further automation via blockchain include insurance, clarity around legal documents such as chain of title, environmental assessments, financial record searches, smart contracts for lease agreements, etc. So in terms of environmental applications of blockchain, the first three items on this slide are all to do with blockchain's fundamental aim of trying to establish trust in a trustless environment, but there are potentially quite deep-seated environmental concerns lurking in the background as well. So in terms of establishing trust in a trustless environment, it's thought that blockchain could potentially help establish attribution in the maintenance of commercially sensitive weather data. You might also be able to manage things like carbon credits and carbon markets securely in attempts to manage global pollution. Also, digital trust systems tied to the blockchain could potentially improve transparency and verification of claims by companies amid accusations of greenwashing. So this is again this idea that you can use blockchain to verify each step in the supply chain. However, there are also quite deep-seated environmental concerns about blockchain, particularly with sustainability, given the computing processing power needed and the electricity generation that goes alongside that. Now, a partial solution to this might include the development of more efficient algorithms so that less computer processing power and electricity is needed. Also, greater use of renewable resources in order to power blockchains. Okay, so this computational element has a potentially costly electricity generation component to it. So in terms of blockchain management of natural resources, it's thought that blockchain could be used to financialize previously unavailable markets such as timber, in exactly the same way as you might be able to sort of split the real estate market into smaller bits. So you just have the market condensed into smaller pieces, so there's more things to go around, buy and sell and transact with. Another possibility is to tie rare metals explicitly to digital tokens. So this then gives you a more refined and a more explicit link between a cryptocurrency and a precious asset of limited supply, which remember was the basic idea behind Bitcoin and its tying of the monetary supply to digital mining processes. But in this case, you've got surety of definition. If you're tying rare metals explicitly to the digital tokens, you then potentially eliminate a core source of the current cryptocurrency market volatility, namely uncertainty over which asset class it belongs to. So if it's absolutely obvious that the cryptocurrency is explicitly tied to a rare metal, i.e. a precious asset of limited supply, then it becomes easier to conceptualize these things as being a genuine currency rather than just a speculative asset that people can buy and sell at a profit.